Okay, today we are starting 5.5, which is looking at special systems of equations. So we always have those special cases. So today we're looking at what happens when we get one of those special cases. So parallel lines, remember, are two lines that are equal distance apart. They have the same slope. They never cross. If you get parallel lines, if we're looking at our graphs and you're solving a system of equation and you get parallel lines, they're never going to cross. Remember, we're looking for the point where they intersect. If they never intersect, the answer is going to be no solution. The one solution are the ones where we've been practicing the first three sections of chapter 5. Okay, so that's where they cross in one point. That one point, x comma y, is your answer. The other possibility is if we have the exact same line. So if we have the exact same line, one is directly on top of the other, then that's going to be infinitely many solutions. In other words, every single point on this line is going to be a solution. Okay, so how do we know whether it's going to be one of our special cases? Let's take a look at what that's going to look like. If it's solving by graphing, easy. You're just looking for what the graph looks like, okay? But what about if we're solving using substitution or elimination? So that's what these examples are going to look at. So if I take a look at the first one, these are in slope-intercept form, so y equals mx plus b. Anytime it's in y equals mx plus b, and it wants to know how many solutions there are, you can compare the slopes. So the slopes on these are the exact same. If they have the exact same slope, what do we know about them? We know they're parallel. So parallel lines never cross. So right away, we know this is going to be no solution. Okay. Let's take a look at number 3. So on number 3, let's use elimination. This one's set up nicely for elimination.
Good morning. Can we please have Mr. Siegel, Mrs. Astley, and Mr. Stevens to Northwest 112 for their meeting? Mr. Siegel,
so sorry about the
Mrs.
announcement. You
Astley,
guys can tell I'm
Mr.
recording it
Stevens
at
to
school.
Northwest
Okay,
112
so
for their
if we're
meeting.
adding our columns, 2x and a negative 2x cancels out. Negative 3x and a negative y cancels out. So I'm left with 0 on this side. On the other side, I have 10 is equal to negative 10. I get 0. So all of my variables cancel out. I got a true statement. So that means they're actually going to be the exact same lines, which means it's infinitely many solutions. Okay, so number 4, let's take a look at number 4. This one's set up nicely again for elimination. So if I add my columns, my x's cancel, my y's cancel, and I get 0 is equal to 9. 0 is not equal to 9. If I get a false statement, just like I did before, a false statement means it's going to be no solution. That actually means these lines are parallel. So if I'd put them into slope-intercept form, I would have found that they have the exact same slope. So it's no solution. And number 5, again, if I add all of my columns, 6x and a negative 6 cancels out, 6y and a negative 6y cancel, so I get 0 equals 0. So I got a true statement. 0 is equal to 0, so this would be another infinitely many solutions. Okay, it is still possible for you to get one solution on each of these. So that's actually what happens on number 2. So if I go back up to number 2, if I add my columns, y plus y is 2y. My x's cancel out, and I have 2y is equal to 4. When I divide by 2, I get y is equal to 2. I can substitute back into one of my equations. So I have that y is 2 equals to 5x minus 1. So if I add a 1 over and divide by my 5, I get x is 3/5. It's okay to get a fraction or a decimal. So my answer would be 3/5, 2. So in this section, they're not all going to be one of our special cases, but being able to recognize what your special cases look like. All right, let's do our one word problem, and then we'll be done with notes. So it says you have $15 in savings, your friend has $25 in savings, you both start saving $5 per week. Write a system that represents the situation, and then it wants to know, will you ever have the same amount of savings as your friend? And it wants to know why. Explain it. All right, so you have $15 in savings, and you're saving $5 per week. So $5 per week plus the $15 you already have. Your friend started with $25, also saving $5 per week. Okay, so if you look at these two equations, you can see they're parallel lines. 5x and 5x, they have the exact same slope of 5, but they have different y-intercepts, so they're not the exact same line. If they had the same y-intercept, they'd be the exact same line. So we have 5x and 5x are our slopes that are the exact same. That means they're parallel lines, and so the answer, will you ever have the same amount? No, we will not. Parallel lines never intersect. All right, take a second and write your summary. How do you know whether it's going to be infinitely many solutions or if it's going to be no solution, both from a graph and from solving it using substitution or elimination? If there's any you have questions on, make sure and mark them. And again, make sure all of these examples were shown in your notes, ready to go for